Okay, let's see if we can explore a better way of finding derivatives, right? One way that doesn't involve a crazy looking limit and a bunch of fractions and radicals. Let's see if we can simplify this process a little bit. So we're going to look at the product rule, or excuse me, the power rule, and the sum and difference formulas here. See if we can simplify this a little bit. So there's a couple of rules that I want to introduce to you. The first is the constant rule. So basically, what we're saying is if I ask you to find the derivative of a constant, that value is going to be zero, right? So if I said to you, let's take the derivative with respect to x of 7, then you would tell me the answer is zero. If I said the derivative with respect to x of 17, it's zero. 170 is the derivative is still zero. The next one is the power rule. And the power rule is going to be one that we see over and over and over again. And really the hard part is going to be how do I apply the power rule when the exponent isn't exactly obvious. But for now, let's focus on one that's fairly simple. We have our function equal to x to the n power. If I want the derivative, it's as simple as bringing the exponent down front and subtracting that exponent by 1. So we're going to look at a couple of problems where we do that and see if we can't make some sense of this. One thing that I do want to point out before we do that is if I have the derivative of a constant times a function, I can simply move that constant out front, hold on to it, take the derivative of my term, and then bring it back in. So I'll show you how that plays out here. This is an example of the power rule. If I ask you to find the derivative, it is really just bring that 10 down and subtract 1 from that 10. So the derivative here is 10x to the ninth. Yeah, this is a whole lot better than finding some limit, right? So here, find the derivative of f of x equal 2x to the fourth. This is an example of what I was saying. We can just take this 2, I'm going to hold it out front, I'm going to bring the 4 down and do the power rule like I normally would. So the final value of my derivative is 8x to the third. And you can see they did exactly that here in the PowerPoint. Just scrolling through, right? If you take a look, 8 is a number. It doesn't have a letter, right? It's a constant. And we said that the derivative of a constant is equal to 0. So here's where things start to, I mean, it's not overly difficult, but what we're doing is we're just kind of adding another layer to the problems that we're working. So here I have the derivative of a sum, right? If I'm adding these things together, I'm just going to take the derivative of the first thing, I'm going to take the derivative of the second thing, and I'm going to add or subtract as my problem calls for. Okay, so let's take a look right here. Find the derivative of 2x to the fifth plus 7x plus 11. Like I say, we're going to take the derivative of each term and just add those together. So the derivative of 2x to the fifth, that's 10x to the fourth, plus 7, right? So here's what happens with 7x. This is an exponent of 1. So I'm going to multiply 1 by 7 and subtract 1 from 1. 7x to the 0. We know x to the 0 to be just 1. And the derivative of 11, that's a constant. So we have 10x to the fourth plus 7. All right, so there are, here's where Newton goes in and they apply rule after rule to finding the derivative of what we just did. Again, you can do it their way or you can do it my way. It's really just a matter of making sure you get the right answer when you're working through these. Okay, so here's one. We're going to find the derivative. Again, we're going to take the derivative of each term. Okay, so I would start with the first one. 7 times 2 is 14x to the sixth. There it is. 5 times 3 is 15x to the third. Now look, right here, there's an error in the Newton PowerPoint. This should be 15x to the second. Remember that we have to subtract that exponent by 1. They have the 2 here, but for whatever reason, I think there's a typo there. The derivative of negative x is just going to be negative 1. Okay, so if you think about it, the derivative of 5x is 5. The derivative of 7x is 7. The derivative of pi x, right? Pi is a constant, so it would just be pi. And then the derivative of a number by itself, that constant is 0. So we have 14x to the 6th, 15x squared minus 1. One last problem to take a look at, right? So I'm going to have the derivative of negative x squared. That's negative 2x minus 4, right? And there we go. Take a look at the Newton homework here. Let me know if you have any feedback, any additional help that you might need. I'd be glad to help you.